Today we are going to talk about Sine Law and when we are able to use this new law. Just remember that previously we talked about right triangle. We said a right triangle is a triangle which has one of the angles 90 degrees, which is shown with a square or a 90 beside it. When you have a right triangle, then you can use any of the trig ratios, sine, cosine, tan, that we talked about in the previous lesson. Now the question is that what will happen if the triangle is not a right triangle, meaning it doesn't have a 90 degrees angle. Let's say we have a triangle like this one. Although this angle looks like 90, this is not a right triangle since it doesn't have the square attached to that angle, or the 90 is not written beside it. It can be 89 degrees, but still we cannot say this is a right triangle. So this means the trig ratios that we talked about cannot be used in this type of triangle. We have a special name for this type of triangle. We call them oblique triangle. These are the triangles that they are not a right triangle. Now, we can use the sine law, which relates the sides and the angles in any oblique triangle, a triangle which is not 90 degrees. If you remember from grade 10 applied or 11, we talked about the sine law in any oblique triangle as the ratio between the side and the sine of the angle in front of it. We said that the sine law says we can write an equivalent ratio between the length of any side A, for instance here, divided by the sine of the angle in front of it, which is angle A, so A over sine A. The same way we can say B divided by sine of the angle in front of it, which is sine B. And the same way C divided by the sine of the angle in front of it, which is sine C. This is one form of sine law. We can also flip all these ratios. We get another equivalent ratio, which is going to have sine of the angle divided by length of the side in front of it, sine A over A, sine of B over B, sine of C over C. So this is another form of sine law. The main question is that when can I use sine law? There are two ways you can think of the problem. Either you go ahead and use the ratios which are here. If your ratio has only one unknown, then you can go ahead and use sine law. But if you write the ratio and you have two unknowns, then it's obvious that you can't use that ratio, that equivalent ratio. So sine law is not applicable. But in general, these are the rules on how to use sine law. If you have a triangle which two angles are given and one side, then go ahead and use sine law. Meaning, if I have a triangle like this one, if any two angles is given, for instance here and here, and also if another side is also given, let's say this side is given, then I can go ahead and use sine law to solve the triangle. You may say how, because this angle is not given. I can use the fact that the sum of the angles inside the triangle is 180, so I can find this angle. Now I have this angle and the side in front of it, so I can write the sine ratio for this. And then I have this angle, and I can use the other side of the sine law to find this side, and the same to find this side. So I can solve the triangle. Another type of situation that you can use the sine law is when you have any two sides but the angle that it has to be known not to be the angle between the two sides. That's why here we said not included between the two sides. Then you can go ahead and use sine law. For instance, I have a triangle like this one. If I know this side and this side, if any of these two angles is known, I can go ahead and use sine law. If this angle is known, then I cannot use sine law. It has to be either this angle or this angle. Knowing these facts, we can just go ahead and solve a couple of problems here. The first problem says, in the triangle DEF, if I know angle E is 95, angle D is 40, and side FD is 38, I have to find side D, meaning I have to find this side. Now, if you look at this problem, I have two angles, this one, and I have one side. If you look at this condition, we said that any two angles on one side is sufficient to use sine law. So I'm going to use sine law here. So I'm going to write D over sine 40 is equal to 38 over sine 95. Now, if I crisscross these, I'm going to get D sine 95 is equal to 38 sine 40. Before I multiply 38 by sine 40 and then divide it by sine 95, I'm going to divide everything by sine 95 before using the calculator. And I'm going to get the D is approximately 24.52 centimeters. Now, just remember, if we wanted to solve this problem by using the second version of the sine law, still we could get the same thing. We would write sine 40 divided by D is equal to sine 95 divided by 38, crisscross, and then divided by sine 95, we would get D is approximately 24.52. Now we are going to go to the second example. We have a triangle XYZ. We know the angle X is 83. We know that the side XY is 2 feet and 2 inches. The question is, first of all, what is angle Z? We are going to use the fact that the sum of the angles inside the triangle is 180, so I can easily write that 83 plus 35 plus Z is equal to 180. I'm going to move these two to the right, change the sign, so Z is 180 minus 83 minus 35. So Z is approximately 62 degrees. Now for part B, we have to find the measure of sides X and Y. So to do that one, since now I have angle Z to be 62, I can write the sine law as, before I do that, I'm going to change 2 feet and 2 inches to inch. So we know that 1 foot is 12 inches. So I'm going to write 2 feet as 2 times 12 inches plus the 2 inches. So I'm going to get 26 inches. Now I'm going to write the sine law. I'm going to say 26 inches divided by sine 62 is equal to, let's try finding side x. X divided by sine 83. Now I'm going to crisscross. I'm going to find x sine 62 is equal to 26 sine 83 divided by sine 62, and x is going to be approximately 29.23 inches. To find side y, we are going to do exactly the same thing. I'm going to write the ratio 26 over sine 62 is equal to y over sine 35. Again, crisscross. I'm going to get y sine 62 is equal to 26 sine 35 divided by sine 62, and I'm going to get y is approximately 16.89 inches. Now let's do one word problem and we can finish off the lesson. The word problem is the following. You have a plane which is approaching a runway of 7,500 meters, this is the runway. The angles of depression to the end of the runway are 9 and 16 degrees. Now remember, the angle of depression is always with the horizon, which is this line, when you are looking down. So this angle is going to be 9 and this angle is going to be 16. The question is, how far is the plane from each end of the runway, meaning this side and this side. Now we also know that this angle is 164 degrees. To do that one, there are two ways we can find this angle here. Either we can use the Z pattern, because this line, the horizon, is parallel to the ground, and line PR is a transversal. So using the Z pattern, we can say that this angle is equal to this angle. So this means this angle is 9 degrees, so this means this guy is 9 degrees. The other way we can do it is that we can say that if I draw the diagram like this one, I know that this angle is 9 degrees. 16 degrees, sorry. I know that this angle is 9 degrees. So this angle here is going to be 16 minus 9, which is going to be 7 degrees. So this angle is going to be 7 degrees. So now I have the three angles inside the triangle. I can go ahead and use the sine law to find the sides PR and QR. So to find Q, I'm going to say that Q over sine of the angle in front of it, which is 164, is equal to, now I am going to write a ratio which has both the numerator and denominator known. So I'm going to write 7,500 divided by sine of the angle in front of it, which is 7. Again, crisscross, I'm going to get Q sine 7 is equal to 7500 sine 164 divided by sine 7, I'm going to get Q is approximately 16,963.1 meter. I'm going to go ahead and do the same thing for side P. I'm going to write P divided by sine of the angle in front of it, which is sine 9, is equal to 7500 divided by sine 7. So crisscross again, I get P sine 7 is equal to 7500 sine 9 divided by sine 7. We get P is approximately 9,627.2 meters.